Wow, first of all, I have a goosebumps, like really, you see? So really big thank you. You know, I really like to bring energy in the room. It's already like kind of like very warm and cozy, and like we are you sing the song. It's amazing. I have this bar of applause. So this like here, it's the regular one that you're doing, like hey, and here is like you go crazy. The goal is there are people there. I see a lot of people standing out there. I don't know what they're doing, but they need to know that here is happening something cool, and then become even more warmer and cozy here. So I need you for that. Okay, so here you start with like regular applause, like hey, you're like, and as the bar is rising, like here, you're going nuts, like really crazy. Like, and I'll allow you, like really, go wild. It's my birthday, okay? Everything is allowed. So let's do this, okay? You ready? You ready? Yeah. So let's start. Let's start with the clapping. Yeah, I see you there in the back. Yeah, you too, you too. Let's go, let's go. Let's go. Let's go. Woo! Yeah! Cool. So, AI. You know, working. So AI is not AI, but always like two things going to work. It's clicker and the presentations. So for me, AI started as like I'm a geek. Okay, I was anyone was reading in childhood the book of Isaac Asimov? Who? So it was like my mantra. Like really believe in that, and like I was dreaming about the robots, and it's literally I was living and reading those books and like living this by dream. And for me, it was like, oh, it's the future. It's like one day it's going to come, and like, oh, robots everywhere, like, ah. Actually, the future is already here. And I kind of like here to tell you what's happening right now, but like it's crazy what's happening out there. So my name is Yonatan, or it's Yoni for friends, and since we're already friends, so you can call me Yoni. All my life I spent in tech, like really working in some bizarre startups. I'm like last 5 years dealing with AI, all kind of stuff, like from the random forests, regressions, linear regressions, like doing all kind of things. But I'm a developer. I just like to build stuff and bring them to the life. You know, today's my birthday, and you know what's the best gift? Is a feedback. Like I really will be grateful for anything that kind of like it's shitty presentation or it's amazing one. Go on my LinkedIn or in Instagram, send me something, post a story. It will be the best gift ever for me. So, actually, my story for this presentation starts with this book. So, I'm like looking for the partner of my life for a long time, and one of my friends recommended me this book, How Not to Die Alone. And I thought it's like very clickbait title. It's actually a very practical book. It's talking a lot about different kind of relationship and attachments and on kind of psychologies between two persons that want to get into the relationship and how to get in the relationship. And like when you finish the book on the last 30 pages, it's literally exercises. It's a worksheet that you need to do to become better at the relationship, to become better partner, to find the love of your life, etc., etc. And like I read the book, I get to this point of the worksheet, and I'm like, okay, but how do I practice? Like, it's a very book that, like, it's an amazing book, but it's written for the millions. Like, for some abstract average Joe that will do this exercise, but there's a me, Yoni, with all my complexities and all that stuff, how do I practice? And also, it's on the paper. I don't want to ruin this book. Like, I need to do it somewhere, somehow. And this is how we build our startup. So I'm building right now my startup. We call it Wisdom. And the main idea is to practice every book, to become wiser, knowledgeable, and experience the book not just from the words, but by doing that, by learning. And we have many different authors. One of them is, like, for example, Eric Rice, Lean Startup. Who read here book, Lean Startup? So it's a very, very popular book about how to build a startup. And there is a practices that you can do. It helps you to define your customers, analyze the risk assumptions, etc., etc. Like basically, after practicing, after reading the book and practicing on our platform, you become the guru of how to build a startup, supposedly. And in a way we build it is like literally you have author that coaching you and practice together with you with all knowledge about yourself. And also it sounds like, I can't play the sound right now, but trust me, it's like sound like Eric Race that's talking to you. And it's even when you see, when you finish the exercises, the practice, it will give you like this summary and the next steps and like all your artifacts. It's literally create your personality inside our wisdom together with the author personality that guides you. So the goal of what we're building is what we wanted that author will personally mentor you, and not only mentor, it will mentor all these practices that tailored for you, and by that we'll create this intimacy between you and the author, like this space, that intimate space, safe space. And for that, we need this authenticity, like that you will feel inside it, that you feel this one-on-one with the author that help you to guide. And actually, we built pretty good platform. Why I know that? Because we have feedback from book authors. So, for example, Dr. Fred Kaufman, he have various books about how to build a conscious business, and he like really tried to break it, like trying to find where's the limits of our, we call it Echo. It's AI avatar, and he like it's insane. He had a team at LinkedIn that tried to build the same thing, and they failed. And we're a small startup of 4 people, succeed to build it, so probably we're doing something right. And how it's work? So basically what we do is couple stages. First, we gather all possible resources that we can find for the specific person. So like all his books, YouTube videos, interview, podcasts, like everything that can be converted to the text, and then use it to build the knowledge and the style. So the first thing that is after we collect the data, we build the knowledge. And it consists from different parts, and main part is the knowledge graph. And I will walk you of how we build it. It's like it actually takes me a lot of time to build it right, but it's very, very helpful. And the second part is actually the style. So basically how he speaks, how he references to you, how he builds the sentences, paragraphs, voice, everything like to make person sounds like him or she. And all this together, this is actually what represents what we call echo. So there's someone echo. By the way, feel free to take the pictures, video, and I will send the presentation. It's for you. So the first part is the knowledge. Also knowledge called RAG, Retrieval Augmented Generation. Who familiar with that? Oh, cool. So you know RAG, I will run very, very fast, Retrieval Augmented Generation. Basically, what does it mean? So if I will go to the small model, for example, like Gemma, and I will ask her, who is Yonatan Levin? It will bring me some bullshit, or what we call hallucination. And what does it mean? It means just the model missing the context about which Yonatan I'm asked, what I'm referring for. So RAG means like we can give model in the prompt part of the context that is missing. So for example, here I took my CV in text format and just put it in part of the prompt, and then the model will be able to answer it properly, who is Yonatan Levin, and give the right references. So how to obtain the right context? This is the RAG. And for example, we use Harry Potter. Why Harry Potter? I'm in love with the Harry Potter books. Who else here is a fan of Harry Potter? Cool. So it's like my and my daughter fun time. We are like reading Harry Potter. We're playing different games with Harry Potter. We even were in Warner Brothers studio, which was like, I recommend for everyone. It's amazing place. So, for example, we want to take Harry Potter book and the index in our system. So the first step is to prepare the data itself. So you're using chunking. So you divide text in using some methodology. Some divided by paragraph, some divided by, I don't know, just the text, books, pages, etc., etc. Like, there's a bunch of strategies how to divide. And then you basically take the paragraph. In our case, we do it paragraph by paragraph. We put it in the LLM embedding. So basically, we translate it to some number representation. And we save it in the database. So for all paragraphs, we go one by one and save it and put it in what we call VectorDB. Not what we call, it's called VectorDB. And it's pretty standard. If you don't know what's VectorDB, basically you can think about is that we have this multidimensional space. And things that are similar one to another, they will be at the same area. So, for example, all persona like Ron, Harry, Voldemort, Dumbledore, they will be in one place. And for example, places like Hogwarts, Azkaban, Hogwarts, they all will be in another dimension, another space. Okay? So if you like look on things that are similar, they will be at the same in the same area. And this is how works the search, basically. So when someone asks who are the members of Order Phoenix, Order of Phoenix, then what's happening is like the question itself is translated to the embeddings, to the number representation, basically called vector. And then we do similarity search. So basically, we're searching in our vector DB what are other vectors that are close to the question. And then we obtain those vectors that represent the paragraphers. And then we can use it in our answer. So basically, we can take the paragraphs that we found, we can put in our prompt and answer the question from the LLM, and then LLM will return some answer, like Dumbledore, Sirius, Hagrid, etc. And there are some tips that I learned in a hard way. So this is my daughter, by the way. As you see, she's like she's a little bit nuts, as all teenagers at her age. And I have like challenges, a lot of challenges. How you grew teenager, and it's like, it's very, trust me, who has a daughter here? Okay, who has a grown-up daughter, like 10, 12? Okay, so it's only me. It's literally nuts. They grow, they go crazy, and there are a lot of challenges that you as a parent need to address and to find a way to communicate with her. So, you know, I'm building the wisdom. So, I want to ask one of the psychologist books about rising child. So I go to our system, I ask him the question, we translate it to using LLM embeddings, translating to the vector. We do this similarity search, find some paragraphs, but surprisingly, all the data that is referenced have the very low score of similarity. So, and I know that she's referencing, like in this book, in the psychology books, they're talking about the psychology, how to raise the child. So why it's not working? And the thing is that not always the question itself, how it's phrased, it's similar to the text, how it's in the book, right? Because the book is the answer, and we actually embedding the question itself. So the tip is, first, didn't find the solution. So the thing is that instead of embedding the question, you're actually embedding the potential answer. So what you do, you ask LLM to generate potential answer. So even if it's hallucination, so it's not correct answer, but the way it's structured, the way it's basically built, and the concept it's used, it will be more similar to what exists in the book than the question itself. So you embed it, and you search, and then the paragraphs it's going to find, it will be much more similar. And then my daughter happy, just give her more food and ice cream. But then my partner, one of my partners, Limor, she said, like, cool, so you have this vector DB, but when I'm talking with Echo, I feel that his answer is not deep enough. They don't provide the same richness of interconnected concepts from the book as I know, and just like their answer is very shallow. And then I started to look in different approaches and discovered GraphRag. So what is GraphRag? Basically, you can think about it's also called knowledge graph. So it's a graph of nodes, where nodes is kind of like entities, and they're connected by a relationship. So all nodes have kind of relationships. Here you have Harry Potter, and have relationship with Hogwarts that he should attend, and Dumbledore his mentor, and Voldemort his enemy. So this is a knowledge graph representation, and we want to use it. So when we ask him, like, who are the members of Phoenix Order, we want to ask our knowledge graph and take his answer and use it as a part of our prompt. And the thing is that it's not only gives us the data, it also gives us how the data is connected one to each other. So it can help us to discover things that really, really close to each other. So I was like discovering, talking with my partners, and said, oh, what's the problem? It's like to build in like 2 days in age of AI. And here's my friend Yuri. He saw me like literally battling it over the weekend and the weekends, even at my vacation, because it's not trivial. But I will save you a lot of time because you're here. So basically, the idea is you take a book, you process it, and you extract the knowledge graph. So it's the way the knowledge graph is built using Cypher. So if you know SQL, a knowledge graph is called Cypher. This is how it's looked. Here, for example, we have a merge, so basically it means to create or to merge if it exists, a type character named Harry, and the variable Harry, and the name Harry Potter, Albus Dumbledore, and there is a connection between Harry and Dumbledore that it's attend Hogwarts. So this is the Cypher. So what the initial approach was like, go again chunk by chunk, use the LLM to extract from the chunk nodes and relationship, and ask him, this LLM, to build Cypher, and then to execute it on the knowledge graph. In our case, we're using Neo4j, and it was total fail. It didn't work. Why didn't work? Because Cypher is very niche language, and there's small amount of examples, and you don't know how to create proper knowledge graph. Like it's really failing time over time, and I find myself like writing JavaScript code to fix the broken Cypher, and it shouldn't be like that. And then I found another approach. Actually, LLMs are very good in generating JSON. So why I'm not will generate the JSON in the proper structure, and then I will convert it by hand. I will convert it to the proper Cypher because it's like one-to-one programmatic problem, software program. So this is what I did, running chunk by chunk, ask LLM to generate the JSON, then running some JavaScript and just converting to the Cypher and executing. And it worked. Oops, animations. And it worked, but it actually didn't help with the merge. Because in the book, for example, it can be referenced in different paragraphs. Sometimes Harry Potter referenced as Harry Potter, and sometimes it's Potter, and sometimes reference Mr. Potter, but in the context, it can mean Harry Potter, or it can mean father of Harry Potter. So the context is really matter, and it's also important what's happened in other chunks, in other paragraphs. So in our case, I was creating a lot of duplicates of the same instance, of the same node called Harry Potter, and it wasn't clear who is it. And it's not enough in the knowledge graph. The node should be unique not only by its name or ID, also by its properties. So if you take this, for example, here you have Harry Potter name, but different properties, like it has the birthday, it has the hair color, and address. For the knowledge graph, it's going to create 3 different nodes because they're all unique. So clearly, I need to do something. So I say, OK, so I will feed the LLM with the entire graph that I created before, right? Feasible approach. So this is what I did. I was taking chunk by chunk, running a Cypher, taking the whole data, feeding it to the LLM. LLM were creating this Cypher, and then execute it. And then when you query for data, basically you take all the graph, you generate for the question and for the data, you generate a Cypher. You ask LLM to generate the Cypher, and then to execute. And it was like looking like a good approach. But again, the problem was that LLM don't know how to create proper Cypher. So no, it didn't work. It's like it's failed miserably. And also, the problem is, at the time, the graph itself became huge. So I was feeding LLM with huge amount of data. And it was taking a lot of time, like 1 minute, to return me an answer for a simple question. So the idea was, I have this similarity search thing, right, that I already used in VectorDB. So why I can't use it here as an entry point? So I was thinking about how I take this VectorDB and incorporate in my knowledge graph, especially where you're using Neo4j. Neo4j support both VectorDBs and knowledge graph in the same thing. So the idea was to take paragraphs, same before, and also put their embedding. So when I'm searching similarity, first I find these paragraphs, and then I can traverse the graph and find the closest nodes and relationship. So this is what I did, basically running chunk by chunk, taking the entire graph, creating this JSON, converted to the JavaScript, and also running LLM embeddings for this paragraph, and combining with my JavaScript, actually we're creating one single node with the embeddings inside and putting inside the knowledge graph. And then in query itself, when we asking the question, basically we convert it to the destination, to some possible answer, convert it to embeddings, do the similarity search on the paragraphs, and then from these paragraphs, we traverse the graph, finding the nodes that are connected to this paragraph. Actually, were extracted from this paragraph, and then executing, converting to the Cypher, and executing in the knowledge graph. and then asking LLM to answer the question based on the data that we obtained. And the thing is, it's almost worked, but until a certain point. Actually, to run this entire graph on creating these nodes is actually were really painful. It was eating a lot of budget. And besides that, it's not only one book, right? So Harry Potter is 7 books. An author can have many books, not just one. And it's starting to eat our budget, and at some point, you're also hitting the limit of the context window, right? So how many tokens you can feed to the knowledge graph. So then, like, I was really betting. We were sitting, like, we were bored vacation, and like, I need to fix it. I need to find a way to how to solve it. And somehow, I came into the idea that, OK, so I can attach these embeddings to the nodes itself. So basically, to the Harry Potter, I can attach the node because it's going to be the same space, right? So I can index Hogwarts and Voldemort and Dumbledore, and then search for them when I need to avoid duplications of the graph. So basically, what I did, I was running paragraph by paragraph. Don't take in account the existing graph. And then in parallel, what I was doing is for the created nodes that LLM extracted, I was running embeddings and then searching for the similar nodes that already exist in the system. And then asking LLM to merge between what exists in my system that was funding by embeddings and what I'm trying to create, and then to create unified cipher and then to run it on the query. I know it's a lot, yeah. But this is like half-year journey in 20 minutes. And it's not all. It was just like one part. It just was knowledge. But here, you can take it and use it as a reference, because now it's very, very simple. And actually, the knowledge was very there. But the next thing that we faced is that we wanted to sound, not just to know about what to talk, but also to sound like an author. And here's a good example, like the difference in the style. So here is the Dan Ariely, which is one of the very famous authors, like selling books millions. He have this irrational behavior, which is like one of very famous books. And I asked ChatGPT, I went to the OpenAI, to the shyness model, and asked him to behave as Dan Ariely, as ask him conversation and to mimic a communication style, and ask him some question about relationship between a girl and my friend, and et cetera, et cetera. Fiction story. And then he gave me this very long answer, and there are like 2 pieces that very. And by the way, just fun fact, like I know there is like huge spike in people that using LLM or ChatGPT as a psychologist or as a friend or whatever. And the thing is, like, it's hallucinating like a crazy. So here's a great example of hallucination. So it's giving me a very convincing answer. And when you look into the details, I found out, like, first of all, it's mentioning something called emotional symmetry. Like, we often talk about it, blah, blah, blah. Dan Ariely never talked about emotional symmetry. And then second thing, he mentioned in my research called short-term pain and long-term regret, and also he's giving me some another answer, and there is no research like that. It just not exist. It invented. The real research was called long-term effects of short-term emotions. And it's completely different from what it's referencing for. And Dan Ariely never gives such a long answer to the question. Why I know it? Because Dan Ariely shared with us huge Excel of almost 1,000 questions and answers. An answer is actually what he answered in real life. So we know for sure that the style is different. And then there's actually a challenge how you take this data, like answers, and convert it to something that LLM can understand and mimic his behavior. And the initial approach, by the way, this is an example from us. Like, this is what our system will answer. It's much shorter and more precise and have like all kind of communications and words that Dan is using. So the first thing was simple, very approach, is to use prompt engineering. So basically, you write this sophisticated prompt, and you give this definition of the persona. And my first attempt was like, it was like OK till a certain level. I just asked him to extract the style from the unedited document. So for example, books are probably not a good source for the style, because books are edited by different kind of people, right? But Interviews, one-on-ones, like podcasts, they're a very good source for extracting the style of the person, like how he speaks, what's the words, what's the garbage words, how he connect different words, how they do how many in different sentences. And then actually we started to some sort of like JSON, and then we feed to LLM to process it and to save these JSONs, and then basically we combine them. And it was based on my early games with the custom GPT to write someone that will mimic my style of writing of articles, because I was writing a lot of articles. And it was like, it's worked, but like, it was like, meh, like, it's OK. And we really wanted to sound like really like the person. So what we did, we basically ran a research. What's define person as a person? So like one of the things we find is ego mantra, and I'm going to tell you what is ego mantra. Is like things like point of view, vocabulary, common phrases, paragraph structure, sentence structure, rhetorical devices, punctuation for marketing, and tone. Like many of the stunts. So what we do the similar things. We take the documents, we process them one by one, we extract the JSON, we take the previous JSON that we created, and we ask LLM to combine them, and we store it in the database as a style. And we do it for the ego mantra, we do it for the style. So ego mantra is something like, we call it, it's like strong belief of the person that he will not share with anyone. Okay, so it's like something that is very, very yours, internal, that's defined you, but it's like you not publicly can admit for that. So I'll give you example, like for Dan Ariely, it would be, because I see the predictable design flaws in human nature, I prove my mastery by engineering clever system that gave us control. So all his books about how to control the environment that is so unpredictable. And this is his ego mantra. Actually, this is what drives him. And it shows us that it's only this is create huge change in LLM and how it's answer the questions. And now, basically, also the style, we call it V2. But the style from actually what made the changes, we ask him to extract the examples for each of the things that we thinking is relevant. For example, like tone, vocabulary, phrases, sentence lexical structure, etc. And we also ask him to give a score. We call it salience, from 0 to 1. And then basically what we do, we get this JSON with the patterns, examples, and score, and snippets. And then we run it one by one. And what we do, we take ego mantra, and then we take the style, and we create something called persona. So basically, we combine all this. We ask it to merge into some certain JSON that later we can use into LLM. And it was like really good. It helped us to reach like really levels where we were competing with LinkedIn. Like think about engineering, how many engineers on the LinkedIn they have that doing this for the people on their platform, and like we, small startup, and we like reached almost the same results. But it wasn't enough. We went even further. So we went to the fine-tuning and to LoRA. So what's the difference between RAG and fine-tuning? So basically, RAG is about knowledge, and fine-tuning is about behavior. In the simple terms, I call it like I have a dog. Basically, like you get the dog from training school, and now you need to train the dog to adapt to your home, like to your own rules, right? So you don't go on the sofa. When you want to go out, you go and take your leash and bark once near the door, etc., etc. So this is the fine-tuning. And fine-tuning is very expensive. Like it's literally what's happening. It's changing the weights of every single node in the neural network. And it's very expensive. It takes a lot of time. And instead of that, there is something called LoRA. And by the way, it's required data set that's much, much bigger than what we had. And there's another way. It's called LoRA. It's low-rank adaptation. So what it's doing, it basically creates this small adapter on top of the existing neural network, and using this layer to give them answers additionally to what already exists in the LLM. And to train it, it takes like, for me, it was taking about like 20 minutes to train Gemma 27 billions. And the way it works is actually very easy, but I was somehow very afraid. Like really, for me, it was fine-tuning was like, like it was sounding for me like I'm not data science. It takes a lot of effort. There's some like validation sets, test sets, weights, and like evaluation, and like what. Until Google released Gemini. So someone asked how many people here are 90% of their code is written by software. And actually, I proud can say, like, 100% of the code is written by this, or Claude Code. Like, I'm using them both. It was very helpful. Like, it's allow us to speed. Like, literally, like, I don't see any point today till we'll raise, like, huge amount of money to hire more engineers because it's very, very powerful if you know how to use it. And it's helped me to build all this process of building LoRA, and actually to understand this very, very simple process. So the first thing is to take this questions answer that CSV that Dan and Riele gave us and convert it to the very simple structure. It's called JSON-L. So basically, it's a JSON where it's like single objects, one line, single object, one line. And this look like this, very similar to API, like messages, role, content, role, content, role, content. So basically, what's the expected answer to the question that the user asked. And then you like separate it into the training set, validation set, and your test set. And then you just need to upload it to the Google Cloud Storage. So we're in the Google DevFest, and obviously, like I'm using a lot of Google tools. Also, I think like, they're doing really great job, and it's very simple. And it's also kind of like tied you, connect you to their own what's called vendor lock, their own ecosystem. But actually very simple, at least at the beginning. So you just take these files, JSON, and upload to Google Cloud Storage. And later, it's just you can think about this file system. And later, you take this set and you just like use it in your code. And how much code you need to write? 3 lines of code. So basically, you have this init with your project ID and the region. And then you called preview train. And you specified which model you want from, in our case, it's like Gemma 3, 27 billion. We specified tuning mode, which perf adapter, which is LoRA. You give him training set and validation set, the one that we just stored in the cloud storage. Yeah, move. And some number, have no idea what does it mean. It just works, trust me, I'm an engineer. And then we give output. So basically, where to store this adapter level. Okay, so this created LoRA, where to store it, and it just, again, store it in the Google Cloud Storage. And it will take about roughly 20 minutes to train, to fine-tune, like very fast. It's like, it's compared like regular fine-tuning for the 27 billion, it can take like half day at least, like 5-6 hours. Here's like 20 half-hour max, and you get your model up and running, so it allow you a lot to experiment. And here I have this process, you can explore it in the Google Cloud console. Then you get the notification that your training is completed. And then how to use it. First, you will see in the Google Cloud Storage, you will see this output and the path of till the final. Like, I don't know why they create so many directories, but it's like output, post-process, node 0, checkpoints, and final. And final, this is basically your adapter, your model. And then you need to There's one thing that took me literally almost 1 week to figure out. I was trying to deploy my model, and I didn't understand why. And just why? Because I didn't had a quota for machine computer. You need it's not regular EC2 instances. You need instances with a GPU. So here is like it's only 6 types of GPU instances that you can use for deploying Gemma. All kind of things, like literally you need to request the quota. I don't know why Google do this way, but you need to request the quota. And then like you specify, I choose to use G2 standard 96. It's at least have 4 NVIDIA GPUs on it. And how you deploy the model, so basically you call this path to your adapter, and you called tune model deploy with specifying which machine type, accelerated type, and you get the endpoint, basically the same endpoint as API that you can use. And the same endpoints that appear in the Google Cloud. So basically, it's just an endpoint that deployed within 5 minutes. It's just up and running, and then you have this URL. URL that you just get. It's like it's very kind of simple, like project, your project ID, location, which region is deployed, and the name of the endpoint. And that's it, basically. And you can run inference. So here is asking, why do I still listen to the radio, watch live TV, when I have access to all the same content from the different streaming services? And you just call the predict, and you get the answers, and that's it. Like simple as that. And here's the results. So remember, we divided to the training set, and then to validation the test sets. So it was the question from the test sets. So we need to validate it actually worked. So this is what the answer that we expected. So it's using 3 dots, all kind of words that like, and it basically this says, Dan really says, is that because we have too much choices. Like why we, yeah, it's too many choices. This is why we struggle and we keep to our old thing. And what actually happened is that the model gave almost the same answer. Like same answer, it says, yeah, it's like you have a choices, you have this analysis paralysis, and this is the reason why you stuck with all the things. So basically, you're scrolling Netflix and not watching it. And like it's almost over. And one thing that left for us is about voice. So we tried all kind of models. Like it's incredible to see how many voice models out there. I found out that like 11 labs, it's the best ones. Like literally, save your time. Don't try any. Like I don't know why I did it for myself, but 11 labs winner by the age. And also the API is very simple. You create the client, and then just like you create the voice. So for example, here is Sam Zell is another book author, and you just specify the audio samples, and you get this voice ID that you can use. And then you just can call another one line of code, text-to-speech. You receive it as a stream. You specify voice ID, format like MP3. By the way, save you tons of time of development on all devices. Like there's a bunch of formats, but on all devices, the only format that is working is MP3. Like on Safari, on the Apple itself, on Android, MP3 is the only one. And then you specify the text that you want to be converted to the speech. Which model you want to use. Like in our case, we allow to configure different model on the fly. And some voice settings. Which voice settings? Basically, there's all kind of like stability, similarity boost, etc., etc. You can play to adapt to style. Like what I'm doing, I'm taking the same phrase from the video of the person, and then I'm like try to play with the settings to make it as much close as possible. And this actually what brings us to almost end, that like this is how we create the person. But it's not the only thing. Like there is more. Like it is just like 2 pieces. But in order to facilitate all of this, and I will give you just like snippet of how huge the system is that you need something that actually managing all this kind of stuff. So in our case, we have this author chat agent that actually have these tools of author knowledge and user memory and author style, and which one of them knows what to use. And like the system is like I showed you how to create the clone of the person, but in order to work fully, you need additional stuff like ranking and guardrails. And something like in validations and something they can do evaluation for you. So it's like the thing is much, much, much bigger, but everything that I showed to you is like good starting point. And why the point of what I'm saying right now is like when you see some guy standing on the stage and say, look, oh, this is the solution, it's not necessarily true because there is no silver bullet. What is working for us maybe will not work for you. So you need to adapt. The thing is that you need to experiment. Like I'm literally was sitting, like the way it was working for me and the way we were succeeding to reach the quality of such a good quality is because we just tried and failed so many times. Like literally, I was failing it, I was cursing, and I have like one person that can validate it here. My friend that I really was struggling, and we tried so many different solutions, and this is what you need to do. Like there's no silver bullet in how to create all these kind of systems. And what I want you to take from this lecture is like to be inspired. Like what we can build today is not just about cloning someone. It's actually like it's crazy how fast the technology is changing our world and everything that we do. So hopefully you can use this knowledge for the good stuff. And just a reminder, the best feedback is like its best gift for me. So like things that you like and dislike. So this is just example people that sent to me on the LinkedIn. And by the way, it's a great opportunity to get new connections. Who knows what you will need next? So QR code, feel free, and thank you for your time.